All right, so I'm give credit to Dr. Shi because I'm using his notes. And what we're going to do is we're going to estimate the area under a curve given this particular chart. And the little tricky part here is that it says use 3 subintervals. Now, what I told you yesterday was whenever you're giving a chart, you just draw lines through the numbers and that sort of creates your rectangles. But if I draw lines through all the numbers, what you'll quickly notice is I'm going to have a heck of a lot more than 3 rectangles. I've got 1, 2, 3, 4, 5, 6. I've got 6 rectangles. And that's not what they want. The instructions here say 3 subintervals, meaning I only want 3 rectangles, meaning I don't put lines everywhere. So I need to erase some things. And so when I erase some things, right, now when I look at this, I've got 3 rectangles, right? I've got my 3 rectangles. And if I'm going to approximate the area using LRAM, or using left endpoints, I need to know what's the width of my rectangle. Well, from here to here is 2. And then I get my height, and I'm going to get and it says, L says I need to get the height from the left y value, which is going to be 4. Now I go on to the second rectangle, and the width of that rectangle is still 2. And I get my height from the left rectangle, which is the left part of the rectangle, which is 1. On this one, the width of my rectangle is 2. I'm going to get my height from the left, which is 6. And this is one of those cases where, honestly, I know you could say this is 8 and 12 and 2, and that answer equals 22. But anytime I can, I like to factor the 2 out, so that gives me a 4 plus 1 plus 6. 11 times 2 gives me 22. And so I've computed, I've approximated the area using the left points. And the argument's kind of the same. How do you approximate the area using the right endpoints? So if I want to do it using the right, well, kind of this idea, look up here and say, okay, well, the width of the rectangle is 2. But now I get my height from the right side, so that gives me a 1. The width of this rectangle is 2. I get my height from the right side, which is 6. And the width of this last rectangle is 2. I get my height from the right, which is 2. And when the dust settles out of all this, let's see, 7 plus 2 is 9, times 2 is 18. So we've computed LRAM, we've computed RRAM, we've got our numbers. Now the problem is we have 2 other things, right? Actually, I think you kind of made this one up. I want to talk, right now I want to talk about this part. And when you're computing height, and I need to draw a picture off to the side. It sort of give the argument for this. So, if you start with, let's just say you start with a graph and you want to estimate your area with rectangles. And, we're going to do like 3 partitions, right? If you get your height from the left, well, when I draw the line this way, we can see the rectangles go over the graph, so this is an over approximation because, we're too high. If I get if I get my height from the right, then I draw this way, at which point my rectangles are below the graph, so we know this is an under approximation. So, what would be, if we're going to use rectangles, what has a potential of being a better approximation, and what has the potential to be a better approximation is, instead of getting your height from just the left or just the right, because one of those is above and one of those below, what if you get your height from the middle? And I don't know if you can see this, on the little screen, but if you get your height from the middle, like in the previous examples, it was clear, we had stuff that was always above, we had stuff that was always below, but when you get your height from the middle, typically what happens is, well, part of the rectangle's below and part of the rectangle's above, right? Here, part of it's below the graph, part of it's above, and so actually getting your height from the middle tends to be a more accurate approximation of the area. So if we just, the way things work is if LRAM says get your height from the left, right? RRAM says get your height from the right, and then MRAM stands for get your height from the middle. So it's called the midpoint approximation method. And here's how that works. Remove this as a distraction. I'm going to show you how it works in a couple of situations. I love using the chart. The chart, I think, is the most efficient way to explain how this works. So if it says midpoint if we're going to get our height from the middle, well, we still have 3 rectangles. And so and this means, and I know it says Riemann approximation method, but it's really, okay, we're finding an area of a rectangle. The base of the rectangle is 2. And what goes here is the height. Now, if I say LRAM, that means you get your height is your y value. So you get your y value from the left. If it's RRAM, you get your y value from the right. If it's MRAM, you get your height from the middle. And so that would be a 3. And so this would be the area of the first rectangle. For this thing, I want to, the base of the rectangle base is still 2. For LRAM, I got my y value from the left. RRAM, I got my y value from the right. MRAM, I'm going to get my y value from the middle, which is 5. And then the last rectangle, though, the width is still 2. If I get my height from the left, I would use a 6. If I get my y value from the left, it would be a 6. If I get my y value from the right, it would be a 2. If I get my y value from the middle, it's going to be 4. And so now I add all these up. So that's 9, 12 times 2 is 24. Right? 9, 3, yeah, 12 times 2 is 24. Now, something very important I need to make sure we all understand. Right? And I'm going to say it once, and I'm definitely going to say it again when I get you back in person, because I think somehow they'll have more staying power. When you compute LRAM and you compute RRAM, right? When you compute MRAM, that is not the average of these two, right? It's very important to understand that MRAM is not the average of LRAM and RRAM. I know sometimes a lot of students think that it is. It's not, right? So that's bad news. Computing MRAM in most cases is actually a bit of a pain. It's actually pretty easy when you have a chart. It's usually a bit of a pain when you've actually got a function. So the AP exam usually doesn't make you do MRAM when they give you a function. But so we computed LRAM, we computed RRAM, we used MRAM. Now, unfortunately, there's this thing, and kind of hinting around this trapezoid. Before we talk about this, we need to revisit some things from geometry. And the thing that I want to revisit from geometry is how to find the area of a trapezoid. So, let's see. Anytime I say trapezoid, I usually think of this picture. It kind of looks like a Pizza Hut symbol. And if this length is 10, this length is 8, and I say that this height is 3, I want to talk about how you find the area of a trapezoid. Yes, I know there's a formula, and some of you may already know what the formula is, and if you do, awesome. If you don't, you are like me, and I didn't have the formula memorized. I always had to think about it. And here's how I thought about it. The way I thought about this was, if my job is to find the area, and the secret to finding area of pretty much any geometric figure, there's always something that's related to base times height. And what makes the trapezoid a little harder than a rectangle is you have 2 different bases. So I think everybody in here can agree that if I do 10 times 3, and I get 30, we know that's too big of an area. That's more than what this is, because your base, 10 times 3 would give us like that rectangle, give us a big rectangle, which is bigger than the area we're interested in. If, on the other hand, I did 8 times 3, I think we could all agree that's going to be too small, because then that gives us this little small rectangle, which isn't the whole trapezoid. So the idea of the formula for a trapezoid is, instead of doing the big base, what we do is we take the average of the bases and multiply it times the height. And so the average of the bases, that's going to be 10 plus 8 over 2 times the height, which in this case is 3. In general, here's our lovely formula for trapezoid. We'll call that B1, we'll call that B2, we'll call that height H. And typically they'll say, if you look in a textbook or anywhere else, they'll say it's B1 plus B2 over 2 times H, or sometimes they'll say it's 1/2 B1 plus B2 times H. I've seen it both ways, and there's probably, they might have H over 2 times all this, and they manipulate it all sorts of ways. But the idea, and the way I always remember it, is the average of the bases times the height. So I'm going to write that up here. So I'm going to say the area of a trapezoid is B1 plus B2 over 2 times H. Okay. All right. Okay, so what does that have to do with anything? Because what we've been dealing with, all day yesterday and most of the day is, let's just do rectangles, and the reason we use rectangles is we draw rectangles. Like when we were approximating the area, we were drawing rectangles. Now we're going to approximate it drawing trapezoids, but our trapezoids don't look like this. Here's how our trapezoids are going to look. Our trapezoids are going to look something like this. Now, it's a trapezoid, right? The definition of a trapezoid is a quadrilateral with exactly one set of parallel sides. There's your parallel sides. Those are your bases. And so if I give you this trapezoid, and I say that this is a 3, and this is a 6, and this is a 4, then the way we find the area of this trapezoid, well, it's the average of the bases times the height. So that's going to be 6 plus 4 over 2 times 3. All right, I hope everybody's okay with that. All right? So our trapezoids are going to look like this. All right? Now, before we do that, I could officially just give you the formula for the trapezoid, and I am. What I am going to do now is I'm going to draw a picture, I'm going to put some values up, and when I draw the picture and I put the values up, I'm going to use numbers to approximate an area with trapezoids, and then with those numbers, I'm going to give you a formula. So you don't need to write down what I'm about to do on the board. Basically, what I'm about to do is explain where the trapezoid, it's called the trapezoidal rule comes from. So here's our picture. Do I have enough room? I think so. So let's say I give you a picture. And I don't know, I kind of like this picture. And so I'm going to draw I've got 4 partitions. And in my 4 partitions, I'm going to draw a line from here to here, a line from here to here, a line from here to here. I'm exaggerating it. Actually, if I'm going to really exaggerate it, I should have done a better job. And so if I draw a line from here to here, 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 I don't know if you can see, but I did it quickly, but if you were to take one of these shapes out, like even this one, what you would see is our little trapezoid, where these are the bases and this is the height. And to make my life a little bit easier, what I'm going to do is just put in numbers that kind of go with this picture. And the numbers I'm going to put in are, this width is 3, this is 3, this is 3, this is 3. Pretend they're all the same. And then I'm going to start with, all right, this is height, I'll say this is height 11, I'll say this has length 11, this has length 8, this has length 6, this has length 4, and this has length 2. I know it's not drawn to scale, but I just need numbers. And so now, what I'm going to do is find the area of this trapezoid, 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 and then add them up in a clever way, right? So that I can generate my formula. And here's how it works. So this is your trapezoid, these are your bases, so it's the average of the bases. So this is going to be 11 plus 8 over 2, and your height is from here to here, so that's times 3. So that's one trapezoid. Next trapezoid, I want this, that's going to be the average of the bases, which is going to give us 8 plus 6 over 2 times my height, which is 3. But this one is going to be 6 plus 4 over 2 times my height. And I want to make sure I have enough room. And then the last trapezoid is going to be 4 plus 2 over 2 times the height. And so all I've done is I've got 4 trapezoids. I just said, all right, average of the bases times the height. Now, here's the moderately clever way of looking at this. Yes, I could just compute the numbers, but I don't want to really just compute the numbers and get an answer. What I want to do is do some manipulation. And what I notice is every term has a times 3 and a divided by 2. And since every term has a times 3 divided by 2, I'm going to factor that out. So if I take a 3 over 2 out of every term, what I'm left with is 11 plus 8 from the first trapezoid. Then I'm left with an 8 plus 6 from the second trapezoid. I'm left with a 6 plus 4 from the third trapezoid. And I'm left with a 4 plus 2 from the last trapezoid. Again, this is just some manipulation. And the final bit of manipulation is I end up with 3 over 2. And here's what I notice. I've got one 11, so I'll put 11 here. I've got 2 8s, so I'm going to put plus 2 times 8. I've got 2 6s, so I end up with a plus 2 times 6. I've got 2 4s, and then I've got a single 2. And now that I've done some manipulation of all these numbers, now I can actually introduce the trapezoidal rule, right? Which is how do you if you estimate the area under a curve using trapezoids. So first, I want to talk about the significance of the 3, right? The significance of the 3 is that's how wide each interval is. That's got a special name. We're going to call that delta x. So our trapezoidal rule is going to equal delta x, which is however wide your interval is. The divided by 2, well, that's part of the trapezoidal formula. I can't really do anything with it, so it's always going to be a 2. But what goes in the parentheses is the kind of interesting part. I know I put an 11, an 8, a 6, a 4, and a 2, and I just sort of made up numbers, but what I need to make sure you understand about each of those numbers is these are y values. Like, this is the height of this point. This 8 is the height of this point. This 6 is the height of this point. So they're actual y values. And so in our formula, when I say that they're y values, I'm going to say that this is y0, right? Because it's the first y value. And then this is going to be 2 of those y values plus 2 of those y values plus 2 plus 2 of these y values, okay, 0, 1, 2, 3, and then plus a single y value at the end. Now, the idea between trapezoidal rule is usually you're given a bunch of y values, and so you write one of the first y values, you make sure you double everything in the middle, and you have one of the last y values. And that's your trapezoidal rule. Now, if that's our trapezoidal rule, let's go back and look at how I would do the trapezoidal rule back with this problem. All right, so here's the rule. Trapezoidal rule says, so remember we go back and we've got our partitions. Delta x, how wide is your partition? That's the width of our rectangle, or trapezoid in this case. In this case, the width of our trapezoid is 2. And so this is going to give me 2. I've got to divide by 2. And then you just pick your y values. These are our y values that we're interested in. So it says I want one of the first y values, so I want 1, 4. I want 2 of these, so that's going to give me 2 times 1. I want 2 of those, so that's going to give me 2 times 6. And then you always want one of the last, and it's going to give you a 2. And now I'm going to work this out. And when I work this out, let's see.
Mr. Travis?
Yes.
So let's say you only have like 3 values. So would it just be y0 plus 2y1 and then
Yeah, you get one of the first and one of the last and 2 of anything in the middle. If there's only one thing in the middle, you only double once.
All right, thank you.
Okay. So now when I work this out, let's see, well that's just 1. And 12 plus 8 gives you 20. So now, these are our 4 methods of approximating area. We can get our height. We can use 3 of them involve rectangles where we get our heights at various spots. One of them uses a trapezoid. Now, here's the interesting part with the trapezoidal rule. Remember how I told you that when you did MRAM, it was not the average of LRAM and RRAM? Turns out, if you average LRAM and RRAM, that's the exact answer you get with a trapezoidal rule. Now, I've never seen a question that actually uses that on the AP exam, but I always tell my students that. And the reason I tell my students that is officially, so normally the types of problems that I give are, I give a situation and I say, find all 4 parts, like approximate it with LRAM, RRAM, MRAM, and trapezoidal rule. Well, if you got to do all 4 parts, once you've computed LRAM and RRAM, the way you figure out trapezoidal is you just average those 2 together. So you've already done the work. There's no point in using the trapezoidal rule. But what I've found over the years is by the time we actually take the AP exam, while you may remember that the trapezoidal rule exists, you may forget that on the AP exam. And so I've actually have quite a few students that say, well, I'm never going to worry about using trapezoidal rule. Anytime someone asks me to find trapezoidal rule, I'm going to do LRAM and RRAM and find the average of them, which is a perfectly acceptable way to do it. And so that's why I say it. All right. Whew. That's a lot of talking. But there's our next 2 things. So now, actually, to be honest, yeah, I want to go through this one. So she had this next example, and I like this. This works better if you have a sheet of paper where you can write on it, which you would have in class, but we don't have that today. And what he's done is he's said here, he says here's a function. And so our function is I don't know if you can read that from where you are, but I'll write it out. The function he's given us is f of x is equal to negative x squared plus 10. So just upside down parabola that's been shifted up 10. And we are interested in approximating the area from 0 to 3, right? I want 3 partitions. So if I were to draw I'm going to go ahead and draw those. Actually, I did not follow the rules I normally pick. What I told you to do is always extend it above the graph, because you never know if you actually might need a line up there. So for part A, it says get your height from the left. All right, well, that's fine. I do this, I do this, I do this. I've got my 3 rectangles. But what I really like about, while it's a pain if you're just given the function, he was nice in that here's a function, but he's also giving you the y values that are important. Which means, if I want to find the area of this rectangle, well, let's see, the base of it's 1. Its height is when I plug 0 in, so I get a 10. Second rectangle, base of this is 1. I get my height from the left. So when I plug 1 in, I get a 9. Base of this is 1. When I plug 3 in, I get a 1, so I get my answer. The next thing he talks about is, so that was LRAM. Let's talk about RRAM. And so now I get my height from the right, which means that I'm here, I move over, I move over, I move over. And so now the base of the rectangle is 1. I get my height from the right, which is, plug in 1, I get a 9. So that's going to give us 1 times 9. Go through this one, the base is 1, I get my height from the right, so I'm going to plug that in, I get a 6. And the last rectangle, the base of it's 1, I get my plug in, I get a 1. 15 and 1 is 16. This one, so I should figure that out. 20. And the next part is I want to do MRAM. And so now, when you get your height from the middle, like your base is still 1, right? In all 3 of these examples, your base of each rectangle is 1. What changes is where you get your height. And so you get your height from the left side or the right side, but now with MRAM, I'm going to get my height from the middle, which means I need to plug a 0.5 in, I need to plug a 1.5 in, I need to plug a 2.5 in. And what I really like about what he's done, and actually what you'll have to do, is you have to plug 1.5 into this function. And he's done that. He's plugged in 0.5 into the function, and that's where you got the 9.75. He's plugged 1.5 into this function, got the 7.75. He's plugged 2.5 in and got that. And so it ends up being, this is a 1. Base is 1, the height's going to be 9.75. Base is still 1, the height is 7.75. Base is still 1, and the height in this case is 3.75. And 10, 11.5, I think that's 11, 9, I think that's 21.25. And the last thing I wanted to talk about, then sort of the last one on this problem is, let's do the trapezoidal rule. And as far as trapezoidal rule goes, it's, you take the width of your rectangle, which in this case is 1, divided by 2, because that's our formula. And then it's, you care about the, you care about this y value, this y value, this y value, this y value. So this, and this. And it's one of those plus 2 of those plus 2 of those plus 1 of those. And let's see, 18, 12. Is that 30, 41? I think I get 20.5. And did I mess up? Yes, I did. That's a 6. That should have been a 25. And so I found the approximate width area of trapezoids, I get 20.5. And shocker, if I average LRAM and RRAM, I get 20.5. Whew. And so now, let's talk about something else. Now these were things I sent out early this morning, so you definitely have this. Although I think we still have the same issue of, you can look at that or look at me talk about it unless you've got 2 monitors. Okay. All right. Same thing. They want, I don't even think I need to do this particular problem. And the reason I need to do this problem is we've already done something like this. We're going to use 3 partitions. And for this, if I want n equals 3, meaning I need 3 rectangles, how would I do LRAM, RRAM, midpoint, and trapezoidal? And what you do when you have a chart, first if it says 3 rectangles, you want to draw it so you're sort of draw your rectangles on the graph, and you draw through the numbers. So I'm going to draw through here, 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 and here. And if you look at it, you can kind of see, okay, I've got a rectangle here, here, and here. I have 3 rectangles. If I just draw lines through every number, then I get too many rectangles. And so I have a base. You can start to see, okay, here's 1 rectangle, here's a 2nd rectangle, here's a 3rd rectangle. Each of these has width 1, so we're fine. We're at 1. LRAM, you get your height from the left side. RRAM, you get your height from the right side. MRAM, you get your height from the middle. And then trapezoid, you use your trapezoidal rule. What I did want to talk about, and this one's the mean one, and they do this frequently. Okay. Very frequently is they'll give you a chart. And I'm not gonna, this will be the last example because I've talked way too much for a virtual class. They'll give you a chart and they'll say, approximate the area with a trapezoidal rule, right? I mean, I could do this LRAM and RRAM or whatever, but let's say I want to use trapezoidal rule. And if I'm going to use trapezoidal rule in this case, here's a problem. Or they won't say using trapezoidal rule, they'll say approximate it with trapezoids. This formula only works if it's equal partitions, meaning they're the exact same width. And if you look at this, can you look at, when you look at your chart, notice these are not the same width? Like this has width 1, this has width 2, this has width 3, this has width 0.6, this has width 1.4, this has width 2. And they do this, and I'm going to do this on our quiz that I give you sometime next week. or you'll get something that doesn't have equal partitions, and so now you have to, how do you do this? If you try to use the rule, it's going to be wrong, right? See, this rule says delta x. That delta x is every partition. Well, if every partition is different, you can't use this rule. What you're stuck with is literally, you got to find individual trapezoids. So when I try to find individual trapezoids, these are, it's the average of the bases. These are your bases, so it's going to be 4 plus 3 over 2 times your height, which is this length. Average of the bases, 3 plus 3 over 2 times the height, which is this distance, which is times 2. Average of the bases, 3 plus 1 over 2 times the height, which in this case is 3. Average of the bases, 1 plus 5 over 2 times your height, which is from here to here, which is 0.6. This one, average of your bases, that's going to give us 5 plus 8 over 2 times your height, which in this case is 1.4. And then here, average of the bases, 8 plus 10 over 2 times your height, which from there is 2. And I'm not even going to work this out because it's just some ugly decimal that I don't really care about. All right, so first I'm going to pause.